Hello guys, now we're going to see the logarithmic decrement. First we see the definition, start from the definition. First, let us define as a natural logarithmic of the ratio of any two successive amplitudes on the same side of a main line. Now, why we have to solve these derivations? Because we want x1 and x2. x1 x2 are the two successive amplitudes. We want that. And the logarithmic decrement term is like referred as zeta. This we will consider it as zeta, and the general formula is zeta is equal to natural logarithmic of x1 and x2. Here x1 and x2 are the two successive amplitudes, and we'll keep this equation as equation 1. Now consider this equation. Let's remember this equation because in previous sum they will solve this equation. We will take this equation now. Just remember this: x is equal to c4 e power minus, this we will take as eta omega t cos into root of 1 minus eta square omega t plus it take as phi 2. We will remember this equation. And now see, now we want t1 and t2. t1 t2 generally we know that this is the time, okay, and let t1 and t2 denotes the time that corresponding to the two successive amplitudes. By finding t1 and t2 we can get the amplitude ratio of x1 and x2. For this we have to rewrite the second equation according to the x1 and x2. Which is the second equation? This is the second equation. We have to rewrite this according to the x1 and x2. Now we will see this. This is x1 and x2. Just we have to put t1 t2. The difference is t1 t2 and t1 and t2. Okay, we have to put this. After this c4 will get cancelled. We will get this equation. This t2 will go up because of this is a minus sign. After this we will get this equation 4. And now let assume this t2, just assume t2 is equal to t1 plus td. Okay, and the td formula is 2 pi divided by omega d. This is the periodic time period of the damped vibration formula. Okay, time period of the damped vibration formula, remember this. And this is also a formula: omega d is equal to root of 1 minus eta square omega. And remember this, these three things substitute in the fourth equation. Now you will get this equation: cos of first this term you have to solve. First we are going to solve this, and first this term right. Now we will solve this. Root of 1 minus eta square omega is omega d. We have to substitute here t1 and phi 2, and this is omega d, and t2 is, which is one, t1 plus td, right? Had to substitute here. After for td we have already a formula, so we have to substitute cross multiply and cancellation. We will omega d get cancel. Afterwards we will get one equation like this. Okay, now we solve the second term. Okay, this term like put equation 5, and now we have to solve the first term. We solved this only. Now we have to solve the first term. For this, first rewrite that equation. After t2 we already know, we assumed that t1 minus td is seen here. Substitute here. After that this plus t1 minus t1 get cancelled. only minus minus plus, so we will get this. After the td also we know, substitute formula here, and omega d also know, substitute here. After that this omega get cancelled, we are only having this equation. This is as equation 6. Equation 6, substitute in this equation, substitute in equation 1. Equation 1 is this, we have to substitute here. So the log of x1 x2, we have to take this term only, not the second term. We have to take this term. So if we getting logarithmic and exponential, this is 1. Okay, well, logarithmic and exponential is 1. So this answer only, the power answer only here we getting. Okay, then zeta is equal to this we got. When the value zeta is very small, then we neglect this term. Okay, otherwise it will be a more complex, I minus j, it will come like this. So we no need this, so we neglect this one. So the value of zeta is, we got here this one. And in graph, this is a zeta, this is zeta, and if the value of zeta also is there, we'll get like this. The value of zeta is not that, it is small, so we're neglecting this, we will get like this curve. And remember this curves. After that there are some cases. See here, if we have number of cycles, then we have to at the end s is zeta is equal to 1 by n. In front we have to add the n, 1 by n log of e x1 divided by xn plus 1. Here x1 is the amplitude of the starting cushion, xn is the amplitude of the after n cycles. This is one the logarithmic decrement. Thank you guys.